Lesson 4.1 Multiplying Monomials. Let's define what we're talking about. A monomial is a number, a variable, or a product of a number and one or more variables. Now, very important to understand here that we're talking about a product of a number and one or more variables. So you can have more than one variable when you have a product, but it has to be a product to be considered a monomial. If you have addition or subtraction, then we're talking about a binomial or a trinomial, etc. A constant is a monomial that is a real number with no variables. Now let's look at a couple rules that are important to dealing with monomials. Product of powers rule. Now we would traditionally look at this right here. We have 4 squared times 4 cubed. Now 4 squared means we have 4 times 4, there's 2 of them. 4 cubed is 1, 2, 3 of them. And when you look at that spread out like that, you see that you have 1, 2, 3, 4, 5 different 4s. So it's the same as writing 4 to the 5th power. So 4 to the 5th power can be written as a shortcut. If you just notice that 4 squared and 4 cubed, we take the powers and we add them together. So that's the shortcut. So if I wrote it in general terms, if I have x to the m times x to the n, this statement right here, this rule, tells us that we are going to add exponents. And again, the rule is that the bases have to be the same. So they are both x's. A power to power rule shows you that if you have, for example, 5 squared and you're taking it to another power, so this is a power to power situation, the result would be the product of the two instead of the sum of the two. So 2 times 3 gives you 6, and you'd get the same answer as 5 to the 6th. So shorthand, you'd have x to the mn, that shows that you're multiplying, is equal to x to the mn. I think we're missing one piece here. It should be written like x to the m, and then in parentheses, raise that to the n power, and then that can go to this statement. I think that should be written differently there. So let's see this in action here. First of all, working on definitions, let's make sure that we know what a monomial is. 23 is a constant, so it is a monomial, so yes. F plus 3, because of the plus, it does not satisfy the monomial requirement. It has to be multiplied, so this is not or no. Here again we have an addition problem, so this is no. Now product, I could rewrite this as 1/3 xyz squared, so it still becomes a product even though it looks like a division problem. So this is, yes, it is a monomial. And again, I can have more than one variable. Next one, it is a product of all these things, again more than one variable, so yes. And am over c, yes. Alright, one correction, I had to double check that. I was concerned about having a variable in the bottom. Here we have a 3 in the denominator, we're okay, but here we have a variable in the denominator, so that does not satisfy the requirement of being monomial. So this one is a no. Alright. Product of powers. Now let's check that rule. We take the constants here, the 5 and the 2, we multiply them, we get 10. And we have r to the 3rd and r to the 7th. We're multiplying, so this becomes r to the 10th. Again, there's nothing in the right side here, but we would multiply 3 times 1, we just get 3. C to the 1, when there's no power, it's assumed to be 1. So c to the 1, c to the 4th gives us c to the 5th. D to the 2nd, d to the 3rd gives us d to the 5th. Notice I'm only combining exponents with variables that are the same. Here we multiply our constants. We get 21. Z to the 4th, z to the 5th. When we multiply them, we'll add exponents, and we get z to the 9th. Next one, we have -4 times -5 gives us a 20. A to the 1, a to the 5th gives us a to the 6th. B to the 1, b to the 3rd gives us b to the fourth, c squared, c to the 1, c to the third. Now when we have power to a power, we said that we would not add the exponents, we'd multiply. So this becomes 3 to the sixth, so 2 times 3. When we have multiple parentheses here, or parentheses and brackets, we start on the inside and work our way out. So this becomes 2 to the, and these two together when multiplied, because it's power to a power, gives you 6. Then we still have the fourth out there, fourth power, so that's 2 to the 24th. Now notice that in these problems we have a number here and not a letter. So we could actually calculate this out and go the next step and say what's the 3 to the 6th power, or what's 2 to the 24th power. But just for the practice of working on the power rule, we'll leave it like this. Alright, so we work from the inside out, so 2 times 2, multiplying powers, gives us 2 to the 4th. To the 4th power gives us 2 to the 16th. Next one, let's simplify the powers first by distributing it. Now notice that all of this inside here is being squared, so this power affects every piece in it. So it's a form of distribution. So this becomes 4 squared. X to the 1 times 2 is x squared. Y to the 6th. Then in here I have to distribute that. Negative 2. I want to put negative 2 in parentheses because that's actually what's being squared. And y squared. And that's all to the third power. So again, I'm going to take 4 squared and actually do that. 16. X squared, y to the 6th. Now we take care of this last power. Alright, again, on the inside I'm going to take care of this. This is actually going to be a 4. Negative 2 squared is 4. And then we're going to have, so 4 to the third power. So this becomes a 4. So 4 to the third power and y to the 6th power. Again, this is a 4. So now we can combine. Now we're not taking powers to powers anymore. We're actually just adding exponents because we now have multiplication of the variables. So we have an x there all by itself. We have y to the 6th, y to the 6th. So we have y to the 12th. And 4 cubed. Now that's going to be calculated. So let me calculate that. Alright, that is 64. So we have 16 times 64. Let's calculate that out. And we get 1024. So I'm going to take that out. And let's write 1024. And we have x squared and y to the 12th. Alright, now here we have a formula. The area of a circle is equal to that, and they tell us what r is equal to, so we have to substitute. So I'm going to write the pi symbol, and I'm going to substitute in what r is, 2ab squared, and it tells us to square the r. So that gives us a situation where we distribute the power, and we get 2 squared, which is 4, a squared, and b to the 4th, because 2 times 2, we multiply powers, and then pi. Alright, last one here, we take a look at, again, distribution. Now, negative 2 to the third power. Negative 2 to the third power is a negative 8. So I'm going to do that in one step. A squared to the third power is a to the 6th, because we multiply powers. B squared to the third, we multiply together again, so it gives us b to the 6th. Here we're going to take care of the inside first. So negative 4 squared is 16. B squared, and then all of that's going to be squared yet. So we get negative 8, a to the 6th, b to the 6th, 16 squared. Calculate that out. So 256. And b to the 4th. Now we can multiply these two together. Negative 8 times 256. So negative 8 times 256. 2048. Negative 2048. And a to the 6th and b to the 10th, because now we add them. Alright, and this ends lesson 4-1.